This is problem D2.38, and we need to design the circuit to have this output equation that it's minus 2v1 plus 4v2 plus 8v3, and the circuit that we have is this circuit here. So it's a summer, right? And basically we need to use, for the values of the resistor, we must have resistor greater or equals to 1k ohm, but we need to minimize the value of the resistance. So the minimum is 1k, and you should keep the minimum to 1k, or like minimize the value of the resistance as much as we can. So if we look at the circuit here, basically if we have just this path here, right? This is just inverting amplifier, right? An inverting circuit. And if you see, we have like several of the same paths, right? So this green one here is just the same as the red one with different values of resistances, right? So this blue one here is also the same, right? So if we look at this circuit this way, like if we apply a superposition of the contributions of each one of these voltage sources, V1, V2, and V3, basically we can see the circuit as a simple inverting amplifier, where the output, the total output V out, is the sum of each one of the n outputs from the contribution of each one of our inputs, right? And we know that VON is equals to minus RF over Rn times Vn, which is our input. So at the end, the equation that we have for V out is equals to minus RF over R1. So this goes from n equals to 1 up to 3, right? Because we have 3 inputs. So RF over R1 plus RF over and V1, right? Plus RF R2 V2 plus RF R3 V3, right? And we want those factors, this one here, to be equals to 2, this factor here equals to 4, and this one here equals to 8, right? So one thing is that we should basically pick the value of RF and then define the values of R3, or start with try to guess which one of the resistors here, R1, 2, and 3 should be, or RF should be the greatest value to get what these ratios here, right? So one thing is that we know that this one, this condition holds, right? 8 greater than 4 greater than 2. So it means that if RF is constant in each one of these ratios, we should pick R3 to be the smallest possible resistance, right? Because if this RF is constant, if we divide RF by the smallest possible resistance, we get the highest ratio, right? So since the minimum value for R is equals to 1k ohm, let's pick R3 equals to 1k ohm. And because for R3 we need to have this, for V3 we need this ratio equals to 8, it basically means that RF should be equals to 8 times R3, which gives us 8k. 1k ohm and 8k ohm, right? But this RF, it's common to all the other ratios that we have. Okay, so now we know RF for all those other two ratios. So for R2, we have, so this should be equals to 4, or let me rewrite here. So this should be RF divided by 4, right? Which gives us 2K. And for R1, we should get RF divided by 2, which is 4K ohms. And those are basically the values of the resistance. So RF is equals to 8K, R1 equals to 4K, R2 equals to 2K, and R3 equals to 1K.